In this video, we'll go over the graphs of rational functions. We'll go over how to find x-intercepts, y-intercepts, horizontal asymptotes, vertical asymptotes, slant asymptotes, and holes. So in this problem, they give you this rational function, and I want you to find the x-intercepts, the y-intercepts, horizontal asymptotes, and vertical asymptotes. Alright, so first, I want to rewrite this function. I want to factor the bottom. Alright, so I need two numbers to multiply to give you -4 and add up to 3. Okay, it's going to be 1 and 4. The 1 needs to be negative, and the 4 positive. You'll have 4 plus a -1 to give you 3. And you have x in these two spots to give you the x squared. Now for our x-intercept, that means that your y-coordinate is 0. In order for this function to give you 0, the numerator needs to be 0. So x plus 1 needs to be 0. So what value of x causes that to be 0? So you subtract 1 from both sides. So x equals -1. So we have an x-intercept at -1, 0. Alright, now we want to find the y-intercepts. Y-intercepts occur when x is equal to 0. So we can take our function and replace the x's with 0. We have 0 plus 1 on top, and 0 minus 1, and 0 plus 4 on bottom. That'll give us a 1 on top, -1, +4. On the bottom there will be 1 over -4, or just -1/4. So our y-intercept would be at 0, -1/4. Next, we want to look at the horizontal asymptotes. So if we look at our equation, x plus 1 over x squared plus 3x minus 4, our degree of the top is 1 because the highest exponent is 1, and our degree of the denominator is the 2. So whenever you have the denominator with a higher degree, your horizontal asymptote will be at y equals 0. That's because you have x over x squared. As x goes into infinity, x squared will be a lot bigger than the top, so it's going to approach 0. Alright, so our y-asymptote is at y equals 0. So to find a vertical asymptote, we need to look at the denominator. Anytime that's 0, that's going to cause a vertical asymptote. So I can easily set each of these, x minus 1 equal to 0, x plus 4 equal to 0, and solve. So add 1 here and here, x equals 1. Subtract 4 from both sides here, x equals -4. So we're going to have vertical asymptotes at x equals 1 and x equals -4. So x equals 1 and x equals -4. So if we look at the graph, our x-intercept is right here at -1, 0. Our y-intercept right here is going to be at 0, -1/4. Horizontal asymptote at y equals 0. So right here, we can see that it tries to touch that line, but gets. You can see it tries to go close to 0, but doesn't ever reach it. Vertical asymptote at +1. You can see here at x equals 1. So vertical asymptote there. And at x equals -4. So you can see one going there. It approaches that line, but never touches it. So in this next problem, we have x squared plus 6x plus 5 over x minus 1. So first we want to find the x-intercepts. Remember, that's when y is equal to 0. So basically make the numerator equal to 0. So 0 equals x squared plus 6x plus 5. And then we want to factor this. So we have our x times x to give us x squared. Now I need two numbers to multiply, give me 5, and add up to 6. So that's going to be 1 and 5. They're both going to be positive. 5 plus 1 gives me 6. Now I set each of those equal to 0. Subtract 1 here. X is negative 1. Subtract 5 from both sides here, so x is negative 5. So I have x-intercepts at negative 1, 0, and negative 5, 0. Now for the y-intercepts, that's when x is equal to 0. So we're just going to replace 0 in for x. So that's going to be 0 squared plus 6 times 0 plus 5 over 0 minus 1. Take it to 0 plus 0 plus 5 and over negative 1. So that gives us negative 5. So y-intercept at 0, negative 5. Now for the horizontal asymptote, we look at the highest degree on the top, which is x squared, and on the bottom x. Okay, so as x goes to infinity, the top is going to be, a lot bigger than the bottom. So that means that we don't have any horizontal asymptotes. So none. So now for the vertical asymptotes, that's when the denominator is equal to 0. So just set x minus 1 equal to 0. Solve for x by adding 1 to both sides. X equals 1. So we're going to have a vertical asymptote at x equals 1. So on this one, when the numerator is greater degree than the bottom, we're going to have a slant asymptote. And to find the equation of that, we take the x minus 1, and we're going to divide that into the x squared plus 6x plus 5. Alright, so we're going to have x here. X times x is x squared. X times negative 1 is negative 1x. I'm going to subtract. So 6x minus a negative 1x gives you 7x. Bring down the plus 5. I need a 7 here, so that's 7 times x give me 7x. And 7 times negative 1 is negative 7. And subtract. It's going to be 5 minus a negative 7, give me 12. So that's going to be remainder of 12. And you do 12 divided by x minus 1. Now this part here is going to be our slant asymptote at y equals x plus 7. Alright, so the graph will look like this. Here are x-intercepts at negative 1, 0. So that's right here. And negative 5, 0. We don't have any horizontal asymptotes. Vertical asymptote at x equals 1. So that's basically here. And then slant asymptote at y equals x plus 7. So that's basically what you see here that separates those two. And your y-intercept at 0, negative 5. So that's about there. Alright, so we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basically see that these two graphs are contained in the same line. So we basic in between those two lines. So up here and up here. It's in between the slant asymptote and the vertical asymptote. Alright, so this problem has x squared minus x minus 2 over x squared plus 4x plus 3. Again, for our x-intercept, our y is equal to 0, so our numerator is equal to 0. Just need to factor. There were two numbers that multiply to give you -2 and add up to -1. That's going to be 1 and 2. That's going to be -2 and +1. 1 times -2 is -2, and -2 plus 1 is -1. We're going to set each of those equal to 0. Subtract 1 from both sides. So x equals -1. And 2 to both sides here. X equals 2. So x-intercepts at -1, 0, and 2, 0. And then for our y-intercepts, we plug in 0 for x. So we get 0, 0 squared minus 0 minus 2 over 0 plus 0 plus 3. So basically 0 minus 2 is -2. 0 plus 0 plus 3 is 3. So we get -2/3. So our y-intercept is going to be at 0, -2/3. Now for our horizontal asymptotes, we look at the highest degree on top and bottom. So we get x squared over x squared. When we had the same degree, we're going to look at the ratio of the coefficients. So we got 1 over 1, which is 1. So it's going to be at y is equal to 1 for a horizontal asymptote. Now for the vertical asymptotes, we're going to look at our denominator, x squared plus 4x plus 3. When that is 0, we're going to have a vertical asymptote. So we're going to factor. So we want two numbers that multiply give us 3 and add up to 4. So that's going to be 1 and 3. And both going to be positive. So we set those equal to 0. Subtract 1 from both sides, x equals -1. Subtract 3 from both sides, x equals -3. So we have vertical asymptotes at x equals -1, and x equals -3. Now one thing we need to check here is if any of these cancel out with the top. So if we factor out the numerator, so we get x squared minus x minus 2. So you need two numbers that multiply gives -2 and add up to -1. So that's going to be 2 and 1. That's going to be -2 and +1. And our denominator was x plus 1 and x plus 3. We can see that the x plus 1s are going to cancel out. So actually we don't have a vertical asymptote there, we're going to have a hole where x is equal to -1. So that eliminates the vertical asymptote, is going to be a hole instead. Alright, so let's take a look at the graph. Alright, so our x-intercept is going to be at 2, 0. So that's here. Y-intercept at 0, -2/3. That's here. Horizontal asymptote at y equals 1. So that's here. Vertical asymptote at x equals -3. So that's going to be here. And there's going to be a hole at x equals -1. So it's going to be here. You can't tell from this graph, but there's going to be a hole right here. So I hope this video will help you understand how to graph rational functions. You're going to have x and y intercepts. You're going to have horizontal asymptotes, vertical asymptotes, slant asymptotes, and holes to deal with. Thanks.